Hey guys, welcome to part 3 of solving IIT JAM physics problems. You know the drill, so let's just get into it. So this first question, it asked me for the magnetic moment, and magnetic moment mu is given by I times A. And to find I, what I first do is I find the uh, time period of revolution, which is 2 pi over omega, and omega here is constant. So then I would just become Q, the charge over the time period. So it's Q omega by 2 pi. And the area of the ring is pi r square. So my mu is Q omega by 2 pi times pi r square, which is Q omega r square by 2, which doesn't match option A or C. So yeah, the option A and C are incorrect. Now they're asking us to find the ratio of magnetic moment to angular momentum L, and the angular momentum uh, L is given by I. At this time, it's moment of inertia I ring times omega, and the moment of inertia of your ring is uh, it's m r square, right? So so my angular momentum becomes m r square omega. So this ratio is called the gyromagnetic ratio. Yeah. So yeah, q omega r square by 2 by m r square omega. So r square omega gets cancelled. You left with q by 2m, which matches option B. Ah, that was it. So moving on to the next question. Uh, okay. This is the approach that I have in my mind. So you know that the uh, in circular motion, the velocity, its direction is always tangential to the circumference, correct? So my velocity vector is its magnitude, but always in the theta hat direction. Okay. If this is okay, how do we actually get this? So we know in the polar coordinate, if you want to write the velocity vector in polar coordinate unit uh, vectors, like this is what you do, right? It's r theta r cap plus r theta dot theta cap. But in this case, your radius doesn't change with time, so this is zero. The the component in the r cap direction is zero, and you got this, right? But theta dot is omega, and r omega is v. So yeah, there you have it. Anyway, okay. Now that we know this, they're asking us to find the magnitude of change in its velocity. So first, at the point P, what is my velocity? Um, okay. Oh, theta cap, unlike x cap, y cap, or z cap, it changes. Theta cap is actually a function of theta, and it is given by minus r sine theta x cap plus oh, it's a unit vector, so there wouldn't be any r. So minus sine theta x cap plus cos theta by cap, right? So its two components are this. Okay, so at point P, we know that theta is zero, right? theta is equals to 0. So this is just sine of 0, which is 0, and cos of 0, which is 1. Okay, cool. And yeah, but don't forget the v, just the v. Okay, and at point Q, I don't know what theta is, so I'll just write it this way, comma cos theta. Cool. And now let me change in the velocity. Let me denote it this way. So it's VQ minus VP, and that is just um, minus sine theta, comma cos theta minus 1. Okay, let me open a new page. Right. Now all that's left to do is just find its magnitude. So it's a square root of V comes outside. That's sine square theta plus cos theta minus 1 the whole square. Okay, I will, so cos theta minus 1 the whole square is cos square theta minus 2, 2 cos theta plus 1, right? And you'll observe that this and this they add up. So I get 1 plus 1, that's 2, 2 minus 2 cos theta, or 1 minus cos theta. Okay, now I need a trigonometric expression for 1 minus cos theta. So you all know that cos theta is actually cos square theta by 2 minus sine square theta by 2. Now I'll write cos square theta by 2 in terms of sine square theta by 2. So then it becomes this. Yeah. So now I get an expression for 1 minus cos theta, which is 2 times cos sine square theta over 2. I'll put that back into the square root. So 2 times 2, that's 4. 4 sine square theta by 2, or 2v sine theta by 2, which matches option C. Yeah, there. Okay, moving on to problem number 3. It is a Zener diode as a voltage regulator problem. The question asks me, okay, for what values of Vi will Zener diode be on? Okay, so to determine the state of your Zener diode, whether it's on or off, you just imagine that you remove it from the circuit and find the voltage across the load resistor, and if it's equal to or greater than the Zener voltage, in this case, which is 20 volts, your Zener diode is set to be turned on. Okay, so let's just do that. So when is your Zener diode just on? Just on means the current through it's theoretically 0 amps, right? It just turned on. Okay, uh, uh, in that case, the voltage across your load resistor would be 20 volts, right? And what would be the corresponding current? Uh, so, so 20 volts, which equals the current across RL times uh, its value of resistance. So IRL is 20 by 1.2 milliamps, which let me pull out my calculator real quick. 20 is divided by 1.2, that's 16.67. 16.67 milliamps. Okay, so that's the value of my IRL, and because IZ is 0, this is the same current that's flowing across R as well. So IR equals IRL, which equals 16.67 milliamps. And IR is the voltage across my VR by 220.67 milliamps. And from this, I can determine V of R. VR would be 16.67 times 0.22. 7 times 0.22, which is 3.67. 3.67 volts. And yeah, so VI, it's just VR plus VRL, which is 23 for 23.67 volts. Okay, so we've determined the minimum VI for my Zener diode to be turned on. Now, in order to find the maximum, I use the given value for maximum Zener current. And it's given to me as 60 milliamps. Oops, 60 milliamps. And yeah, again, IR, this current that's going through this resistor, it splits into IZ and I IRL, right? So so IR equals IZM plus IRL. And see, once your Zener diode is on, the voltage across load resistor will always be fixed. It will be equal to your Zener voltage. Uh, so so the potential at this node is always 20 volts. So would be this 20 volts. Okay. Now I'll just use basic Ohm's law and write this as Vi minus 20 by 220 equals 60 milliamps plus. I've already determined IRL here. I'll just write it down here. 16.67 milliamps. Okay. Uh, so Vi minus 20 equals that's 76.67 milliamps into 220. Okay. So let me just do that real quick. 76.67 times 0.22. Okay. 16.86 is what I'm getting. Plus 20. That would be VI max, that I will call it. And that is 36.86. Okay, cool. We found the minimum and maximum. Now let's check what values of input voltages are between this. That is between 36.8 volt and 23.7 volt. And it's only option 2 and option B and option C are between these values. So that would be the correct answer. Okay, thank you guys. That's all for today. I'll be posting another video soon. Bye bye.